Find the two values of theta, for which tan theta over 2 is equals minus 1 over 3. And here, where theta is between 0 and 4 pi. Okay, it's unusual. We wouldn't have seen that much in the book. First thing we might notice, apologies, I miswrote it. First thing we'll notice here is that the tan theta over 2 gives us a negative answer. So we check where is tan negative in the sine quadrant and the cos quadrant. Next thing, we get our reference angle by getting the tan inverse of 1 over root 3. We're dealing in radians, so I can see the tan inverse of 1 over root 3 is pi over 6. So I mark my reference angles into my unit circle, always between the line and the x-axis. Starting at 0 and going counterclockwise, how far do you rotate to get to the first one? Not quite as far as pi, but pi minus pi over 6. For the second one, not quite as far as 2 pi, but 2 pi less pi over 6. Alternatively, you could refer to it as the other direction as just negative pi over 6, whatever suits. Once we get our 5 pi over 6 and 11 pi over 6, don't forget to add your 2n pi. And now it's at this stage that I can bring the 2 over, which is dividing the theta, to multiply. So once you have your 2 run across, you have your two values for theta are 5 pi over 3 plus 4n pi and 11 pi over 3 plus 4n pi. And now we can fill in our values for n. Remember, we're not to exceed 4 pi. Remember, 4 pi is 720 degrees, so we cannot go beyond that. So we can see that 5 pi over 3, when 0 goes in, is valid because it's less than 4 pi. 11 pi over 3 is less than 4 pi, but as soon as I put in n, I go over the 4 pi, so these answers here are not valid. So my only two answers here are theta is 5 pi over 3 and theta is 11 pi over 3.